Hello and welcome to another video. In today's episode we are going to talk about something that you will face if you are installing Arch Linux on a real computer, not in a virtual machine. Bare metal, as some would say, ignoring the most important part of a computer, which are the semiconducting materials, not the metals. But anyways, let's talk about installing Microcode on your Arch Linux installation. And before I jump into today's topic, why don't you consider subscribing to this channel if you are interested in this kind of more in-depth style Arch Linux discussions slash tutorials. So with that out of the way, we will discuss in today's video how to install the Microcode packages which will keep your computer safe and up to date considering your CPU. And so this video will focus on not just installing these things, but will solve a very specific problem which will happen if you use Arch Linux as your secondary OS in a dual boot situation. So let's say you have like a Linux Mint or OpenSUSE or whatever, or even Arch Linux as your primary distribution, and on the same computer you are dual booting with Arch Linux and your secondary operating system is Arch Linux. It doesn't matter what your primary one is. If you are using grub for dual booting, this video will help you load the Microcode on your system in a second Arch Linux or secondary Arch Linux OS in the dual boot order. Of course, if you are only booting only Arch Linux, this video will also contain all the information for that, but then you will have a much easier job than when you are dual booting. So for that, let's take a look what exactly is a Microcode. So of course we can go to the source of all knowledge related to Arch Linux, which is the Arch Wiki, and we can start reading up on this. But the basically best idea would be first to follow this link to Wikipedia, which will tell us that Microcode is a computer hardware technique that interprets a layer of organization between the CPU hardware and the programmer visible instruction set architecture of the computer. What a mouthful. So what does this sentence actually mean? So the processor basically does things to information. It gets some kind of instruction that will tell it like what to do with some kind of data. And these instructions can be very complicated in today's system, and this Microcode is basically saying that the programmer who is writing the software on this processor has a set level of instructions that can write code in, but these instructions are not directly related to what is exactly the processor is doing, but basically the processor breaks up one of these programmer visible instructions into like several steps of instructions that are directly related to this CPU itself, so CPU instructions. And this technique basically allows that the same instruction set can be used on processors with different internal workings. And so basically the Microcode is a justification, has a lot of justifications are there. For example, that these CPU instruction sets are not hardwired exactly anymore, and well, you can basically change the processor's behavior by changing this Microcode, and it has also a lot of benefits on the bugs side. So basically, if there is some problem with the processor, it's not working properly, maybe you can just change this Microcode instead of throwing away the processor and switching it out with a new one with different hardware logic. And so for this purpose there is this writable control store, which basically this writable control store is where the Microcode is located, and this allows the CPU manufacturer to basically allowing the bugs, for example in this Intel Core 2 and the Intel Xenon processor, that these bugs could be fixed by just updating the microcodes rather than requiring the entire chips to be replaced, which is good for the hardware vendor and good for the end user too. And what is really more related to our current day and age is that computer security vulnerabilities that are allowed by the not really perfect coding of these microcodes, like the Spectre and Meltdown problems. These updates, these kind of microcode updates can help mitigate these problems, and we can of course install these with Linux, FreeBSD, Microsoft Windows, or there is like another option just using updating the motherboard BIOS, which is usually the least user-friendly of these methods. So that's why we are using Arch Linux, or rather the Linux kernel's version for that, which is the Linux Microcode loader, which supports these kind of different methods. And usually, so we don't want to build in microcode, because for that we would need to recompile the kernel or something like that. But this early loading method is usually what we are doing, and for that we have to install these microcodes for the processor that we have. It's either the AMD Ucode package or the Intel Ucode package, or if you're installing Arch on a removable drive, maybe you have to install both of them. And so in this Arch installation, I already have my Intel Ucode package installed, and everything for that has been done. So basically I'm going to show it to you on my new installation, which is same computer but different drive, and I will show you how to install the matching microcode for your processor. So let's restart and jump into our console there. So to see what kind of mitigation or microcode we have to install here on this computer, then we have to check it using the lscpu command, and I will pipe it into less so I can scroll here. So you can see that I have an Intel CPU, and there is a list of all the possible vulnerabilities that are available in this computer. So I will install the microcode using the sudo pacman-s intel-ucode command here. So here, instead of Intel, you should type in AMD if you found out that you have an AMD processor. So if your manufacturer is AMD, then you will have to go with the AMD-ucode package. So of course, sudo password, and let's come on, just a Y. Let's install it. Let's retrieve the packages and then install them from the official repositories. Okay, so now this has been done. We have to configure our bootloader to load these and include these patches basically when we load up the system, and for that we will have to go to configure grub again. So if we take a look around, we need to understand that even though the this Intel microcode that I've just installed got installed on the system, so this is the the mounted system, and in the boot directory beside these image files, the init.ramfs files, we also have the Intel eucode.img, the Intel microcode image, which should be loaded together with the Linux init.ram FS, the initial RAM disk, and for that, in general, we can just run the grub-mkconfig file or command if we are using grub. Of course, if you use different bootloader or boot manager, then you will have to proceed by the commands that are described here. But for me, I will be going with the grub-mk-config-o/boot/grub/grub.cfg, because that's where my stuff resides, and so you can see that it found these images. And so this one is the OS prober. What the OS prober is doing, it is basically generating the config file for my dual boot system. So if I go to the file manager here, so this is my mounted system, I can go back to the boot. So this is my main system here. Here you can see that I have also the microcode, but that one has not just Linux but also Linux LTS. And here where the grub config resides, and we will take a look at this file, and we can see here that basically for our main entries, like the Linux LTS, we have this init-rd for the microcode and the LTS, but it does not generate it for the fallback image, which you know, maybe the microcode has a problem, and then you can try to run with the fallback image and that won't contain it. Is it a bug? Is it a feature? I have no idea on that. On the Arch wiki it's mentioned as a note, so might be a bug, might be a feature. But if I go down, so if you don't have a dual boot system, then until this point your bases are covered. It installed it. But if you are trying to do what I'm trying to do with the OS prober, then it will unfortunately not work. It will only not add the microcode image. That is something that you might have to do manually. So just remove the OS prober and use instead some kind of custom grub entries. And so that's what I will be doing, and I'm not going to show you how I am writing it, but I will show you the results. Okay, so to achieve what I wanted, I needed to edit a certain file. So don't forget that you have to do it on the system which is your main, so your primary OS, which contains the bootloader, or from which you install the bootloader. And I am in the /etc directory, and in that I need to go into grubd, and in that there is this 40_custom, and that will contain what you need, and this is what you should be editing. So what I did here is basically I just copied whatever was OS prober doing and what it put into the original grub.cfg file on the boot drive, and did some small edits, like Arch Linux for testing is one of the things I did. I also added the root, basically identified by the UUID instead of the /dev/sdb3, and of course I also added the init-rd/boot/ucode.img, so it will also load the inter microcode. So let's take a look at the generated. Let's generate first. Of course, we have to generate the new grub config file. So for that, let me jump back to my console here, and we will sudo grub-mkconfig-o/boot/grub.cfg. So it will generate, of course, all the entries that are there. So I still have the OS prober installed, so that will do that, and then it will also add my additional configuration file there. So let's go and can I just gvim here? gvim/boot/grub/grub.cfg, and yeah, it opened, so I just had to put it on the screen here. So what we got is, so this is what I did manually, and this is what OS Prober did. So OS Prober, of course, did not have the Intel microcode and had the root device specified by the drive letter and the partition number, and I changed that to the UUID and added the Intel microcode. And for that, I basically took a look at, for example, this menu entry of Arch-Linux with Linux. And so here what I could see is that this is how it does the UUID thing. It also adds this like RW and log level 3, so maybe I should do that too. RW log level 3 and quiet. We can add that to our grub file there, and it also has this. So you can see that here it does not have the /boot, it just has /intel ucode.img, and also here Linux is also only /vmlinux vmlinux-linux. Why? Because here the root is set to this drive. So why? What is this here? So here we can see that the boot partition has a different UUID than the root partition. So this means that when we are booting our system, this basically this boot partition is mounted first. This is where all the grub itself resides, where some of this the initial RAM disks for my main system also reside on this drive. So we will load these things from that drive. But in the case of this one, I have to use as the initial kind of drive from which we are bootstrapping our system after the bootloader is loaded. I have this other partition on the other drive, and this is where it resides inside the boot directory what we want to load. Same here. So what I want to do is just add this RW log level equals 3 and quiet into my what do I want? Sudo gvim, so it will be into etc/grubd/ this 40 thing here. Yeah, I should not do gvim. Oh my. Yeah, it's not the graphical program should not be run as root. I don't know why it still have. So my computer crashed during editing this file for some reason, and now even I handled this. Let me go to the end of this line and append, and what I need is RW and log level equals 3 and also quiet. Write and quit, and we will regenerate the file. So now the next time we take a look at that stuff, we can take a look, and if it works then we can just remove the OS prober. Okay, so let's go back to the GVim here, and let me put it on screen. So now here we have the same setup as we have for the basically all the other boot entries here. So what we can do now is just remove OS prober. I don't want that there anymore, so I will just sudo pacman-r. Do I need to rs, I guess, to remove OS prober, and it will remove OS prober and nothing else. Yes, very good. And now make the grub configuration file again, much faster. Here we take a look at this in GVim again, then you can see that now there is no OS prober, only custom. And now I can finally reboot my system and check if the microcode is working or not. So let's do just that. Okay, so now you can see that Arch Linux for testing is the new menu entry that I managed to add. So let's start up the system. It has the dev/sdb3 checked, and now it is starting, and you might not be able to see what's written here. So let me log in with my password. And now that you can actually read what is on the screen, hopefully, let's test if the microcode is loaded with the dmsg command, and let's grab microcode from here. And now we can see that microcode updated early to revision whatever, and microcode update driver. So these things appear here, which means that in this installation of the Arch Linux system, we finally have the microcode properly loaded, and we don't have to worry about the possible exploits that can exploit the faulty microcode or the original microcode. So, success, finally. So this concludes today's journey. I hope I could present you some interesting information on how to work with grub and how to install your microcode even if you have like a dual boot situation. So this will also work, of course, if you are dual booting with any other distribution, as long as Arch Linux is not the main distro, it is the secondary distro. So it doesn't matter if your primary distro is Arch or Linux Mint or whatever else. If your secondary system on the dual boot situation is Arch Linux, this is how you can load the microcode. So I hope you found this video useful, and if you did, please consider giving me a thumbs up. You can check out my playlist about Arch Linux related videos, or subscribe to the channel, and you can also leave a comment if you have any questions or comments about today's topic, and I will see you in the next video. Bye bye.